Okay, so I'm going to go over question number 10 from section 6.2 in the homework. And let's see. Let's start off by getting, now in the homework they'll have you choose this. You'll select this. You've sure you've seen this already. It'll be a multiple choice option. But it's easy enough to get a graph here. It's 8x cubed. So the general behavior of the cubic function will be, a shape like this. Basically, that's the shape. The coefficient of 8 just makes it a little steeper. But that's the general shape, and that should suffice as far as what we need to get the job done here. Okay, and it's bound by the line y equals 0, which is, of course, just the x-axis. So we want to be bound by the x-axis and then the line x equals 1. So let me draw the line x equals 1. We'll say that's like, we'll say it's like right here. Oops. Let's make it vertical like this. All right, so here's the line x equals 1. Let's change its color. We'll make it red. Here we go. All right, so this is the line x equals 1. We're going to be going about the line x equals 2. We'll do another line here. So we'll say this is x equals 2. Change the color of that as well. Make this one red. All right, this is the line x equals 2. So that's okay, we'll use the red color for that. All right, so we're going to be rotating about this vertical axis here, the line x equals 2, and we want the region of this function that is bounded by the x-axis, y equals 0, x equals 1, and then of course the function itself. So hopefully you notice the only region that's actually bounded by everything, all right, by the x-axis, the curve, and x equals 1, is this region here in green. So in the book, this might be a little bit more detailed picture. But, doing this by hand, should be accurate enough for what we need. So in this case, you actually can do this with shells or with disks. And there's two different approaches for this. I'm going to say because this is a 6.2 question, that we're going to do this with the disk method. Or actually, in reality, it's going to be a washer method. So remember, whenever we're doing the washer method or the disk method, we want to draw the strip that we will be rotating perpendicular to our axis. So we want to be perpendicular to this axis, x equals 2. So there's our strip. And whenever this thing rotates around, it's going to be hollow in the middle, right? Because there's this whole region here where the region that's bounded doesn't exist. So we're going to have this gap. If you rotate this around, it's going to be hollow in the center, right? So there is, all of our disks are going to have washers because of that hollow center. So we need a representation for the volume of one of these strips when it gets rotated, this resulting solid. That way we can add it up using the fundamental theorem. So let's start with this. The width of this strip is going to be dy, right? Because we're partitioning the y-axis. If you look at this strip, the width of this thing is definitely breaking up a value of the y-axis. So we want the width to be dy. That means everything's going to need to be in terms of y. So we'll consider that moving forward. So we have width of dy. We also have to get the area, the surface area of the outer and the inner disk, right? So ultimately we can subtract them and then just get the value that we need. So let's start with the radius for the outer disk, which is going to be from the center all the way out to the edge, right? So if you notice, the outer reaches of this function is going to be from the curve, 8x cubed, all the way to the line x equals 2, right? So we're going to be defining this distance. Now notice the radius is always going to be 2 minus whatever value we're at on the function here, whatever the x value is here. We're going to represent it in terms of y. But it's the function itself, right? As the strip moves, the radius is always going to be from 2 less whatever value we're talking about on the function. So let's start with that. We've got pi, and we've got a radius squared times dy. Now remember, when we're orienting ourselves horizontally like this, we want to do right minus left. So we've got 2 minus this x here. Remember, we have to represent this in terms of y, because our differential, our width of our disk here is dy. So when we say this is the x, we need to make sure we define, right, it's this function. we got to make sure we define that x in terms of y. So if you solve for x here, it's just a matter of, let's see, dividing the 8 on both sides. So you're going to have y, we'll say it's y over 8 or 1/8 y. And then we're going to have to take the cube root of both sides, right? Because this is still x to the third. So x is going to be, now notice the cube root of 8 is actually just a half. So we have a half there. That's the 1/8 raised to the 1/3 power. And then the cube root of y, of course, we'll just write it as y to the 1/3. So this is our x value. That's this x here represented in terms of y. So I'm probably going to need to add a little bit more room here so we can plug it in. We've got 1/2 y to the 1/3 squared dy. Right? So that's the outer disk. Now we have to subtract the volume that we get for the inner disk. That way we only get the volume of that washer, right? That hollow disk in the middle. Or a washer being a disk that's hollow in the center. So let's subtract out the volume of the inner disk. Now the radius for the inner disk, if you notice, is just going to be a nice simple number, right? We got pi. This radius, if we go from right to left, notice the region stops here. Well, the rightmost x is 2, and it stops here at x equals 1. So if we do 2 minus 1, our radius is just simply going to be 1. Right? It turns out the inside is just going to be a simple cylinder. So we got pi, r squared, and then of course the width is still dy. All right, so let's get a simplified expression for this volume. That way we can work with it. So let's see, we can pull the pi out. We've got, we'll deal with this here in a second. 2 minus 1/2 y to the 1/3 power, whole piece squared. And then this is just going to be minus 1 dy, right? So this is the expression for that volume there. I guess I don't really clean it up that much, right? It's just basically the same thing. So we need to add up all of these shells and think, or all of these disks here, washers. And remember, we're working with dy, so we need to use as our limits of integration a y value. So consider the fact that our lowest y, of course, is going to be 0 because it's bounded by y equals 0. The upper boundary is going to be this intersection point. And that's just as simple as, where does this line x equals 1 intersect with the function? Well, that's easy enough to do because you just say, well, you know x is 1, what is y going to be, right? If you plug x equals 1 into this function, you get 8 times 1 cubed is just going to be 8. So we want to go from 0 to 8. These are the y values, remember. So from 0, this strip's going to move at y equals 0 all the way up to y equals 8, that intersection point. And then we've just got to, well, here, we'll put the pi on the other side since it's a constant. And I'm going to go ahead and cube this binomial now to make the integration easier, right? So if we, square it, So if we square this binomial, right, we square the first term, we get a 4. You're going to multiply these together and double. So if we do 2 times 1/2, it cancels out. We just get a 1. But then when we double it, we're going to have a 2 y to the 1/3. And then plus, squaring this, we get a 4th y to the 2/3. And then we got a minus 1 dy, right? Now, as far as cleaning that up further, let's see, we can combine some like terms. We'll go from 0 to 8. We got the pi here. Look, we got a 4 minus 1 is 3. You don't have to put this in any particular order as long as, they're separate terms. So we got 4 minus 1 is 3. We've got a 2y to the 1/3, and we've got a 1/4 y to the 2/3 dy. All right, so now it's just a matter of integrating this. Let's see, we got 3y minus, if we add 1 to this power, it's already 1/3, so it's going to be 4/3, right? 1/3 plus 1 is 4/3. And then dividing by 4/3 is multiplying by 3/4. And 3/4 times the value 2 that's already there should be 3/2 y to the 4/3. Plus adding 1 to this power, right? 3/3 being 1, 3/3 plus 2/3 is 5/3. Dividing by 5/3 is multiplying by 3/5. So we should have 3/5 times 1/4 is 3/20. 1/4 times 3/5 is 3/20. And then we've got y to the, we said that was 5/3 And now, can't forget about the pi. There is still a pi out there. But we can evaluate from 0 to 8, and the upside is when we have the 0, we don't got to worry about subtracting out a 0 because all these terms are going to be 0 when you plug in 0. So we really just got to be careful to plug in 8. All right, so we've got pi times 3 times 8 is 24, minus, you can do this in the calculator, but it looks like the cube root of 8 is 2. 2 to the 4th is 16, and then we've got 16 divided by 2 is 8 times 3. Is that a minus 24? Okay. We'll do that again. The cube root of y is 2. 2 to the 4th is 16. Yes, okay. And then we've got plus. Again, we're plugging in 8 here. The cube root of 8 is 2. 2 to the 5th is 32. And so let's see, we've got 3 over 20 times 32. Whatever that makes. Let's figure that out. All right, so the final answer, look, this cancels out, right? So it's just going to be, what is that? 16 over 10, 8 over 5, 8 over 5. 24/5, I believe. You simplify that, right? Let's see, because that would be a 10 and 16, 5 and 8, 8, yes. All right, so this should be the answer here, 24/5 pi. Again, we did that. This could have been done using shells, by the way, so this might be a good problem to look at if anyone cares to see it using shells as well. But this being a 6.2 question, we did it with discs, ended up being a hollow center, so we call that washers, right? Because we're rotating about this line x equals 2, and the whole region doesn't even exist from here onward. So there is a hollow center, so I'll use the washer. Hopefully that helps. If anyone has any further questions on the problem like this, just let me know. I can make another video, or I can even meet with you one-on-one if you'd like. But hopefully that helps, and take care. Thanks. Bye.